The engineers risked their lives to erect the tallest bridge pillars in the world, but now connecting these pillars had become a challenge for them. During the construction of the world's tallest Millau Viaduct bridge in France, the engineers faced a significant problem. They had to place pre-made road sections between the two pillars. Each road section weighed as much as 25 locomotive engines, and there were a total of 8 such sections. No crane in the world could lift 5,000 tons of weight up to a height of 800 feet. If a crane was placed on top of the pillars to pull the road sections, the pillars could easily collapse inward due to their height. The taller the pillar, the weaker its top would be. This issue was nothing short of a nightmare for the construction team. The delay in resolving this issue was causing further delays in the Millau Viaduct's construction, and every passing day was costing the construction company a fine of $30,000. Welcome once again to Fusion Arc Videos, viewers. The Millau Viaduct in France is the world's tallest bridge, constructed in 2004 at a cost of €394 million. It stands 1,125 feet above the ground, making it a marvel of engineering. It is even 45 feet taller than the Eiffel Tower and is situated so high that it often appears to float above the clouds. The engineering company that took on the challenge of building this bridge found themselves entangled in a massive project. In the hills of France, landslides and stormy winds blowing at speeds of 130 km per hour were pushing their work from difficult to nearly impossible. A 4-lane highway of such height had never been built before, and no one has dared to build one since because everyone knew that the Millau Viaduct had pushed the limits of engineering beyond their breaking point. On the other hand, building this bridge had become a necessity for the French government. In the 1980s, the French government was troubled by the tourists traveling from France to Spain, especially during the holiday season. The traffic would pass through all the cities, causing severe congestion. The city of Millau, which lies 1,500 feet deep between mountains, was particularly affected. The traffic coming from northern France had to descend a zigzag road and then climb up again. This zigzag journey took hours, and on top of that, the traffic jams in Millau city alone would waste an additional 6 hours. Therefore, to facilitate tourists, the French government decided to build a motorway from Paris to Spain. The motorway from Paris to Millau could be built straight, but Millau presented a dead end with its 1,500-foot-high mountains and the Tarn River running through the middle. The only way to bypass this complicated condition was to build a bridge almost as tall as the mountain itself. Saying this was easy, but doing it was nearly impossible. When this plan was being made in the 1980s, the tallest bridge in the world was California's Golden Gate Bridge. Not only was it a suspension bridge, but the height of the road from the water's surface was only 250 feet, which is 6 times less than the height of Milau's mountains. Considering this, many experts said that building a bridge at Millau was impossible, and even if such a tall bridge was constructed, it would be like inviting a massive disaster. For years, the dream of building the bridge remained just that, a dream. But when traffic jams became unbearable, the French government had no choice but to take this bitter step. From design to construction, the engineering team faced 3 extremely difficult challenges. First, erecting the world's tallest bridge pillars, and that too on a slope. Second, placing a 36,000-ton 4-lane highway on top of those pillars. And third, installing steel pylons on the bridge. Each steel pylon was twice as heavy as an Airbus A380. And above all, they had to perform all these tasks hundreds of feet above the ground. For this, the world's best architect, Lord Norman Foster, was hired. He had already made a name for himself in bridge design. His job was to design a bridge with the delicacy of a butterfly, yet strong enough to withstand thousands of tons of weight and fierce winds. Even a small mistake in this design could have disastrous consequences. 2 years later, while Lord Norman Foster's design was still on the drawing board, his reputation took a big hit. A few years earlier, he had designed London's famous Millennium Footbridge. In the year 2000, when the bridge was opened to the public, it began to sway badly just from people walking on it. There was a major but hidden flaw in its design. The bridge had to be closed again for repairs, which cost an additional £5 million. If a similar design flaw was found in the Millau Viaduct, which is 15 times taller than the Millennium Bridge, the potential disaster would be unimaginable. After years of effort, Foster finally presented a magnificent design. The bridge was to have a total of 7 pillars, and the road would be curved on top of them. However, the challenge was that pillar number 2 would be the tallest, while the other 6 pillars would be built on a slope. The challenge wasn't just about bringing this unique design from paper to reality. The construction team, which had the courage to take on this project, was given a deadline of only 4 years. After the deadline, the fine for each passing day was set at $30,000, or approximately 24 lakh rupees. In October 2001, the construction of the Millau Viaduct began. The bridge was designed to last for 120 years. The construction started with laying the foundation for the pillars, but soon after, geologists delivered bad news. They warned that the area underneath contained fractured limestone, meaning there were many gaps between the stones. These cavities formed caves where a unique type of bacteria lived, known as blue mold bacteria. This bacteria is used to make the world-famous Roquefort cheese. While it is perfect for cheese, it is not suitable for building the foundation of the world's tallest bridge. Despite the warnings, the work on the foundation began. But then the very thing they feared happened: a dangerous landslide occurred. This landslide buried the foundation of the first pillar under rocks, but fortunately, there was no damage. The construction team stabilized the slope with cement and continued with the project. It took approximately 200,000 tons of concrete to build the 7 massive pillars of the bridge. To accomplish this, a factory was built on site. This was reinforced concrete, using 16,000 tons of steel bars. If the steel used in the Millau Viaduct were laid out straight, it would cover a distance of 4,000 kilometers, equivalent to the distance from Dubai to China. The architect's design had now become a burden for the construction team. At this point, they wondered if they had made a mistake by taking on this project. The problem was that the shape of the pillars was not uniform. They were thicker at the bottom and thinner at the top. They could only build 4 meters of the pillar at a time. Heavy steel frames were used to make a mold, into which concrete was poured. After one 4-meter section was complete, the mold was removed and then reassembled for the next section. Simply raising and lowering this 15,000-ton mold was consuming a lot of time. This race against time was intense. The casting of the pillars was taking 6 months longer than expected. But the challenges faced by the engineering team were not limited to this. If the location of each pillar wasn't pinpoint accurate, the road section placed on top of it would never be straight. If the bottom of the pillar was even 10 centimeters out of place, it would create a 6-meter difference at the top. To achieve this pinpoint accuracy, GPS technology was used. Multiple satellites in the sky helped determine the exact position for the pillars, ensuring the foundation was laid in the correct spot. Even during the casting of the pillars, GPS was used to make sure that the top of the pillars ended up exactly where they were supposed to be. Time passed, months turned into years, and by November 2003, the 7 pillars had reached their final height. The 245-meter-tall pillar number 2 had become the tallest pillar in the world. However, there was no time for the team to relax because the next phase of the bridge's construction was the most difficult, placing the 2.5-kilometer-long road section at such a great height. This road section weighed approximately 36,000 tons, which is equivalent to the weight of 90 Airbus A380s. During this process, even a small mistake could cost lives and millions of dollars. Let me remind you that during the construction of New York's Brooklyn Bridge, 34 workers lost their lives. Similarly, in 1970, 35 workers died during the construction of Australia's West Gate Bridge. Considering these historical losses, the decision was made to build the road section of the Millau Viaduct in steel portions. The construction team faced a major challenge: how to lift the massive 5,000-ton steel sections of the road to a height of 800 feet and place them precisely between the tallest pillars in the world. Lifting this weight directly was out of the question, so the engineers decided on a highly innovative solution. They would slide the road sections into place horizontally. The plan was to build the road in parts at either end of the bridge and then slowly push it out towards the middle from both sides. Massive hydraulic jacks were used to push the road sections inch by inch, while steel cables held the sections securely in place. This technique allowed the engineers to move the enormous road sections at a rate of about 9 meters per hour. It was slow but incredibly precise. However, moving the road sections was not the only challenge. The wind blowing across the valley was another serious problem. Winds could reach speeds of over 130 kilometers per hour, and at such heights, these strong gusts posed a real danger. The engineers had to carefully monitor weather conditions and halt construction during high winds to ensure the safety of the workers. By March 2004, the two ends of the road were nearing each other, but there was a final gap of about 60 centimeters that needed to be closed. Even though this might not seem like much, bridging this gap without error was critical. The two ends had to meet with millimeter-level precision. Engineers used a highly sophisticated laser guidance system to align the two ends perfectly. Finally, on May 28, 2004, the two sections were joined together in a grand ceremony. The Millau Viaduct's road was now complete, and it was one continuous highway suspended high above the Tarn Valley. But the work wasn't done yet. The bridge's steel road deck needed to be stabilized. For this, 7 massive pylons were to be erected, each holding cables that would help support the road. These pylons were twice as heavy as an Airbus A380 and needed to be hoisted hundreds of feet into the air. To do this, powerful cranes were mounted on the road deck itself. The pylons were then secured to the bridge using strong cables made of high-strength steel. Finally, after 3 years of non-stop construction, the world's tallest bridge was ready. On December 14, 2004, the Millau Viaduct was inaugurated in the presence of then-President Jacques Chirac. The bridge opened to the public 2 days later, and it immediately became a symbol of France's engineering prowess. The Millau Viaduct is now an iconic structure, celebrated for its innovative design and the sheer bravery of the engineers and workers who made it possible. It holds multiple world records. Not only is it the tallest bridge in the world, but it also has the highest road bridge pillar ever built. Despite initial concerns, the Millau Viaduct has stood the test of time and remains a masterpiece of modern engineering. The bridge's design allows it to withstand high winds and earthquakes, and it was built to last for at least 120 years. The viaduct has dramatically reduced travel time between Paris and the Mediterranean, improving traffic flow and boosting tourism in the region. But perhaps the most remarkable thing about the Millau Viaduct is that it represents what human ingenuity can achieve when faced with seemingly insurmountable challenges. Today, it's not just a bridge, it's a monument to human ambition, courage, and skill. Thank you for watching today's episode on Fusion Arc, where we bring you the stories behind the most extraordinary feats of engineering. If you like this video, make sure to hit the like button and subscribe to our channel for more amazing stories like this. Let us know in the comments which engineering marvel you'd like to see next, and don't forget to click the bell icon to stay updated on our latest content. See you next time.